Okay, so we're going to talk about the summary of what these different transformations do to these functions. Maybe you guys can help me out here. So number one was if we took f of x and we added something, right? So we're thinking of c being positive. You kind of split it back and forth and you can see different things. What do you think that does to the function?
The origin moves up, I see.
Yeah, the origin moves up. In fact, all of the y values, because you think of f of x as like the y value, I'm moving it up by c, or if c is negative, I'm moving it down, right? So this is a shift up or down, right? Or I guess I should say up, because in part two, we're going to make it negative, right? So that's a shift up. And then separately here, we have 2 is f of x minus c. So we're thinking of c as a positive number, and that's a shift down. Right? So the y values are going down by that factor of c. Any questions so far? Nobody wants to talk because I'm recording. All right. So the next part was, what if we have f of x minus c? This was 3. It's a little counterintuitive. I think you all know that it goes to the side. Which side does it go to? It goes right, which seems a little backwards to me because I think up is positive and right is positive, right? And when number one, the plus you moved up, but now the negative shifts it right. And so this is a shift to the right. The way I would think about that, let me maybe use a different color. I used to think when it's just f of x, when x is 0, that's when you get f of 0, right? But now if I want f of 0, I have to take all of that and make it 0, right? And so that means x should be c. And c is a positive number. It's to the right. Does that make sense? So the whole graph is translated. Wherever f of 0 was, that's now you got to make xc to get that value. Does that make sense? So that's why it's a shift to the right. And then for 4, you would need negative c to get f of 0, right? So this is a shift left. And one thing to keep in mind with the picture I gave you on that Desmos graph, and I'll include a link with this video so you can play with it again, is that the domain is only from -5 to 5. The up and down shifts, those change the range, but these change the domain, right? That shift shifted the whole domain over. The whole graph was moving. All right, so number 5 here. And really 5 and 7, 7's one added later. 5 and 7 should go together, so this will be a little out of order. So this is negative f of x. What happened when you did that? Yeah, it flex over the x-axis, right? And that's because, remember, f of x is like the y value, and I took all the y values, and if they were positive, I made them negative, and if they were negative, I made them positive, right? So I switched those. Let's go to number 7, so let's skip a little, because let's keep talking about those. F of negative x. That was then, unsurprisingly, that was a reflection over the y-axis, right? Because I took the x's and I switched them inside. And a general rule for these is that if you're messing around inside the parentheses, you're messing with x. Outside, you're messing with f of x. You're messing with y, right? All right. Let's go back to 6, and then I'm actually going to add a number 8. So this is cf of x. And so, again, I'm messing with y, right? And what did this look like? Yeah, it stretched it. If you made c high, you pulled it this way. And if you made c less than 1, right, you kind of smushed it, right? You shrank it. So let's put both those. So c greater than 1, that was a vertical stretch. And if c was between 0 and 1, that was a, I'm just going to write smush. That's a nice mathematical term. Right, it kind of compressed it. That's the word I should use, compress. All right, and then 8, I'm going to say, what about f of, we'll use a different letter, how about dx here? Now inside, that's the same kind of stretching and compressing, but it's horizontal. But also, if d is large, that's a compression, and if d is small, that's a stretch. It's backwards, just like the shifts are backwards, okay? Because if d is very large, then to get those values when x is very large, I just need a small x now, right? Because I'm going to multiply it by that very large d. And if d is very small, you know, for example, if I want f of 1, but d is like 100th, let me write that down. If d was 100th, and I wanted to get f of 1, now I would need x to be 100. Does that make sense? So f of 1 used to be where x is 1. Now it's where x is 100. So that's a stretch this way when d is small, a horizontal stretch. So let's write that down. So if d is greater than 1, that's a horizontal compression. And if d is between 0 and 1, that's a horizontal stretch. All right, so let me stop that.